angular momentum. Previously, in the circular motion, in the linear motion, we discussed the angular momentum, linear momentum, right? Linear momentum. Now we discuss the angular momentum. Angular momentum. How can we find the angular momentum? Okay. Topic is angular momentum. Angular momentum. Write down. It is the moment of linear momentum. Moment mean gurne. Right? Moment is the angular momentum is right. I will go and I will explain. After that we can write. Okay. Listen. When you take the rotating disc like this, it is rotating in this direction with omega RAD S minus 1. This axis O. We can take the masses. M1, M2, M3, M4, R1, R2, R3, R4. When you take it like this, okay, we can take, we previously discussed in the circular motion, what is the tangential velocity? We can take the tangential velocity values. We can take the tangential velocity values. What is the tangential velocity? V1 equals R1 omega. V2 equals R2 omega. V3 equals R3 omega. V4 equals R4 omega. Like that, we can take the tangential values. Tangential values. There is a definition. Angular momentum is a symbol is L. Angular momentum, capital L, equals the moment of linear momentum. The moment of linear momentum of particles. What? The moment of linear momentum of the particles. The summation of the particle. Right? That mean when we take in the M1, the momentum is M1 V1. The distance is R1. The distance is R1. Therefore, the moment is M1 V1 into R1. Momentum of the each particle. Right? M2 V2 having a momentum. Therefore, M2 V2, what is the radius or what is the momentum? M2 V2 into R2. R2. M3 V3 R3. M4 V4 R4. Likewise. Right? L equals M1 V1 R1. M2 V2 R2. M3 V3 R3. M4 V4 R4. Like that. Then we can simply say V1 equals to the tangential velocity. That means M1 V1 equals R1 omega R1. M2 R2 omega R2. M3 R3 omega R3. M4 R4 omega R4 plus. Therefore, we can simply say M1 R1 square omega, M2 R2 square omega, M3 R3 square omega, M4 R4 square omega likewise. When we take in the omega, omega is a constant, we can simply say M1 R1 square, M2 R2 square, M3 R3 square, M4 R4 square. Okay. Therefore, what is this one? Omega into sigma I equals 1 to n mi ri square. What is mi ri square? Mi ri square mean what is that value? You know, this is the mi ri square. This is the I. I mean moment of inertia. Moment of inertia. Therefore, we can simply say L equals, this is I omega I, that means L equals I omega. It bit similar to the, right? We can compare the linear motion also. What is the linear momentum? Linear momentum means equals to mass into velocity. Mass into velocity. In linear motion, mass is the inertia to the motion. Inertia to the motion. In rotational motion, I is the moment of inertia of the motion. Therefore, I equals moment of inertia of the motion. Therefore, in linear motion, momentum equals to the P equals mv. Likewise, in rotational motion, L equals to I omega. L equals to I omega. I mean moment of inertia. Moment of inertia. In linear motion, inertia. This is moment of inertia. Omega equals angular velocity in linear motion. In linear motion, velocity. Likewise, it is bit similar to that. Okay. Okay. Write down the topic angular momentum in brackets capital L. Then write the moment of the moment of the moment of linear momentum, moment of linear momentum particles of the particles of an object of an object of an object is called is called is called angular momentum. Angular momentum. Angular momentum. Angular momentum. Okay. Okay. Write down this one. Draw this one. Draw this one initially. Draw this one and write down this one. This is angular momentum. Angular momentum. Write down this one. Right. Okay. When an object is when an object rotates with the v velocity, uh, this is the when object is rotating the angular velocity omega. Let think like this. When an object rotate like this, rotate in omega velocity, omega angular velocity, we can simply say L equals I omega. When object object having a velocity like this. It's having a velocity with v. The axis of rotation is r. Normally we can say L equals what? Moment of the linear momentum. Linear momentum equals mv. Momentum equals mv into r. We can simply say mv r. L equals mv r. Write down when object having a velocity simple v, when object having a velocity simple v, velocity simple v, and from the axis uh, simple r distance from the axis, simple r distance from the axis, simple r distance from the axis. Okay, we can simply say L equals mvr. It is not a formula. I think we can simply get that one. Find out the dimension of L. Find out the dimension of L. Unit of capital L. What is the dimension of the capital L? Angular momentum. Give me the answer. Yes. M L T minus 1 into L M L square T minus 1. The unit of L kg M square S minus 1. Kg M square S minus 1. Okay. Okay. L is the vector of the scalar. In linear motion, is that linear momentum is the scalar or the vector? Linear momentum. Linear momentum is the vector. Why? Yes. If the object having a linear momentum, P equals mv, what is the direction of the linear moment? The direction of the velocity. You know that thing. Likewise, the if we take the velocity, the direction of the velocity as this direction, the direction of the P is this direction. Okay. Therefore, the what is the angular momentum? Angular momentum when object is rotating with the omega, angular momentum L equals I omega. L equals I omega. Omega is the vector. Omega is the vector. The direction of the omega can be taken as the clockwise direction or anti-clockwise direction. Previously we mentioned that clockwise or anti-clockwise. But the direction of the omega can be taken using the right hand rule also. Right hand rule also. How can we find the right hand rule? It is very easy. We can use the right hand rule. When we take the right hand, when we when we place our thumb in this direction and the rotation direction, in 4 fingers into the rotation direction, this is a rotation. We can simply say omega in this direction. Previously we discussed this one, omega in this direction. Therefore, omega is the vector, L also is the vector. Therefore, omega is the vector. Therefore, L equals to the vector. L is also the vector. L is also the vector. Therefore, omega L in the upper direction. Therefore, rotational direction, we force this four fingers into the rotational direction, the omega in this direction, and also the L in this direction. Therefore, in this case, we can simply say L equals I omega. What is direction? Clockwise. Clockwise. And also, we can simply say L equals I omega in clockwise direction when we place the right hand in this direction, no? In this direction, right? I think you have to clearly understand that one, because the vector type of the uh, angular momentum is very important, huh? Very important. The omega in this direction, the rotation in this direction, we have to focus this four fingers into this direction. Therefore, L into the surface. Therefore, into the surface, how can we write into the surface? Like this, right? Into the surface. Hurry. Okay. Write down. Write down. Capital L is the capital L. Angular momentum is a vector. Angular momentum is a vector. The direction of capital L. The direction of capital L. The direction of capital L. Similar to the direction of the. Similar to the direction of the. Similar to the direction of the omega. Omega. Similar to the direction of the omega. Normally, or generally, the direction of omega represented, the direction of omega represented, generally, the direction of omega represented as the rotational directions, as the rotational direction, as the rotational direction, in brackets, clockwise, clockwise, or anti-clockwise, clockwise or anti-clockwise, clockwise or anti-clockwise, clockwise or anti-clockwise. The actual direction of the omega, the actual direction of the omega can be taken, by right hand rule, by right hand rule. By right hand rule. Okay. This right hand. When you place the right hand, the thumb in this direction and the other fingers in this direction. When we focus the other four fingers into rotational direction, the L and omega in this direction. Okay. Okay. Write down this one. Direction of angular momentum is very important thing. Huh? When we discussing the conservation of angular momentum, it is very important. Right? It's very important. Write down the example also. Example 1, example 2. Okay, write down the examples. Write down the example also. Write down the example also. This one and this one. Okay. Write down the examples. Okay. Then write down the problem. Then write down the problem. Write down the problem. Write down. We having a mass. We having a mass of 5 kilogram. 5 kilogram. And radius of gyration k equals 5 kilogram. And radius of gyration k equals radius of gyration k equals 0.2 meter. 0.2 meter. Meter. When it rotates, when it rotates, when it rotates, with 60 radius radius minus 1, with 60 radius minus 1, with 60 radius minus 1, angular velocity, angular velocity, angular velocity, find out the angular momentum, angular momentum, find out the angular momentum, find out the angular momentum. K equals point, find out the angular momentum. Okay, quickly find out angular momentum. Quickly find out the angular momentum. Quickly find out the angular momentum. Hurry, find out. Okay, what is the angular momentum? Yes, radius of gyration mean I can, we can find the simply I equals mk square. M mean 5 into 0.2 square. That means 5 into 0.04. That means 0.2 kg m square. L equals I omega. L equals I omega. 0.2 into omega means 60. That means 12. What is the value? I mean kg m square. Omega mean rad s minus 1. Right? What is the unit? Unit is this one. Right? This is the unit. Very large unit. Right. Then write another topic. From this, we have to do the lot of problems after this. Right. Write down the topic. Torque. 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 Or movement kelat kenabe. Torque movement. This is the similar thing we discuss in the statics. Movement or torque. In the force, we discuss this one. Torque mean we use in torque value. In force equilibrium, we know the torque or moment. In this case also the similar. There is no need to memorize all things. Write down if an object in linear acceleration there is an external forces external force external force acting acting on object acting on object acting on object acting on object comma if an object in angular acceleration if an object in angular acceleration angular acceleration the external torque should be applied the external torque should be applied external torque should be applied external torque should be applied. Right, I am taking these examples. I am take these examples. Right. Okay. Considering this example, see, tau equals F into R. Tau equals what? When considering this case, we know what is the momentum. Momentum equals to the force into perpendicular distance for force multiply into perpendicular distance from the uh, center from the center to the force line of action, right? Let's take the first example. Give me what is the torque value. This one. We know torque F force acting with R distance. With R distance, it is perpendicular. The line of action of the force is perpendicular to the R. Therefore, torque equals to the direction, this direction. So O equals to the F into R. Force into the distance from the line of action of the force. Right. Write down the first one. Write down the first one. Write down the first one. Okay. It is very easy. Let's move to the another one. Okay. Let's take this one. What is the torque? What is the torque? So it's rotating. It's like a force couple, no? Not force couple. The force couple should be F1 and F2 equals to the same. It's not a force couple, but they are F1 and F2. What is the value? F1 into R, F1 into R plus F2 into R. See, F1 into R, F2 into R. Both are in same direction. F1 into R, F2 into R. Both are in same direction. Therefore, tau not equals this one. See, very easy, huh? Very easy. Okay, write down that one. And also find this one. Find this one. Find the value for this one. Find out the torque value. I think these two are clear to you. These two are clear to you. This one and this one is clear to you. Find out the value for this one. Find out the value for this one. Find out the value for this one. Give me the answer. It is very easy. It's like a moment in force. In force lesson, we discussed the what is the moment. Likewise, that thing. Very easy. So, first of all, we have to take the direction of the motion. I take the tau O in this direction. F2 into what is the line of action, perpendicular distance to the line of action of the force. F2 into perpendicular distance from the line of action of the force. R2 minus F1 into this direction R1. Right? So this it is the value. It is the value. It is the value. Right? Find out the value for this one. Find out the value for this case. Find out the value for this case. It's rotating in this direction. Give me the value. What is the torque? Oh. What is the torque? Give me the value. We have to take the torque. Right? We have to take the torque. Therefore, we have to take. Therefore, we have to take. We have to take. What is torque? Mg, the distance, it's rotate L over 2 from L over 2. Mg L over 2. Like that. Mg L over 2. Right? Likewise, we have to take the torque. Right? Mg L over 2. Right. I think torque values is clear. If the find out the torque value for this one, if pulley having a write down this one. Okay. Find out the value T1, T2, T1, T2, and the R distance R1, R2. Rotating in this direction. Find out the toe. In the in the Newton's law, we discuss the pulley problems. In the Newton's law, we discuss the pulley problem. In rotational motion, also we discuss the we discuss in after this topic, we discuss in the pulley problems. But there is the small difference. In Newton's law, the pulley are considered as the smooth frictionless pulley. Why is that? Smooth mean it not having a friction. Therefore, it's taken as the smooth pulley, right? There is no friction. Likewise, when we take in the value, when we take in the likewise the when we take in the acceleration in the Newton's law, we do not consider the rotation of the pulley. But in the rotational motion, the pulley is rotating. Why? There is an external torque. Torque means it's rotating in this direction. Why? The tension are not equal. T1 greater than to the T2. There is friction. Why? If there is no friction, it is not rotating. No? It's not rotating. Why? Because of friction, it is rotating. Right? Therefore, if it rotates in this direction, T1 should be greater than to T2. Right? What is the tau value? So T0 equals to the T1 R1 minus T2. It's very easy. Huh? Very easy. But you should have to clearly understand the concepts. Right? Okay. Not R1, R2, R. No? Same value. R. Okay. Therefore, T1 minus T2 into R. Sorry. I. Okay. Then the same pulley, there is no radius, no? There is no change in the radius. Therefore, okay, write down. After that, in linear motion, force is defined as in linear motion, force is defined as the rate of change of linear motion. Force is defined as the rate of change of linear motion. Linear motion. Likewise, in brackets, right? Newton's second law. Newton's second law is force is equal to the rate of change of linear momentum. Right? Newton's second law. Close the bracket. Likewise, in rotational motion, torque is defined as the rate of angular momentum. The rate of change of angular momentum. Delta I omega over T. Right? Well, in Newton's second law, F equals delta mv over T. Right? In Newton's second law, linear motion, I take delta mv over T. In linear motion, we take the m as constant because of the mass of the object is constant. Delta v over T, F equals ma. Right? Likewise, equals delta omega t equals to k delta I omega t, right? K as 1, equals delta I omega over t. This is the first equation. This is the first equation. Then we can find below equals I is the constant delta omega over t. What is the delta omega over t? Delta omega over t equals to change angular velocity. Rate of change of angular velocity. Right? Therefore, we can simply say what? Therefore, we can simply say it is alpha. Therefore, equals I alpha. Equals I alpha. This is number 1. This is number 2. Likewise, the linear motion, F equals delta mb over t, F equals mb. Right? Very easy. Okay, write down. If you want, write also this one, linear motion. This is rotational motion. Okay. Write down this one. From that, we have to do a lot of problems. Okay. Write down this one. Write down the problem. Write down the problem. It is very easy. We have to use the F equals MA likewise. F equals MA or M. Write down the special point. Equals I alpha is considered. Equals I alpha is considered in one rotational direction. In one rotational direction, in brackets, clockwise, or anti-clockwise. In one rotational direction, clockwise, anti-clockwise, clockwise, anti-clockwise. As positive, and other negative, another negative. We have to apply tau equals RA alpha as positive in one direction, as negative the tau that means torque in another direction are negative. Okay, right. Write the problem. A uniform cylindrical plate, having I equals 5 kg m square, having I moment of inertia I as 5 kg m minus 2, 5 kg m minus 2 m2 5 kilogram m square uh, increase in its angular velocity, increase in its angular velocity 10 rad s minus 1 to 20 RAD S minus 1. 20 RAD S minus 1. Within 10 seconds. Find out the torque that should be applied. Find out the torque that should be applied. Find out the torque that should be applied. Okay, find out torque that should be applied. Okay, hurry up and find out Newton meter. The torque, the units of torque is Newton meter, right? So we can find omega naught equals 10, omega equals 20, T equals 10 second, alpha. We have to find alpha. Omega equals omega naught plus alpha t. Alpha mean omega naught equals to 10, 20 plus alpha into 10. That means 10 alpha into 10. Alpha equals 1. RAD is minus. Okay. Then how can we find tau equals I alpha? I alpha. I mean 5. Alpha mean 1. Therefore 5 Newton meter. 5 Newton meter. Okay. Okay. Then write down the problem. A solid cylinder, a solid cylinder, a solid cylinder having a mass of 50 kilogram, 50 kilogram, 50 kilogram, and the radius 1 meter. Radius 1 meter is set up to rotate freely about its axis. About its axis. In elastic string is attached at the one end of the cylinder and wrapped around the cylinder find out the tension that should be applied
Sir,
to the string
find out
the cylinder to rotate the cylinder with an angular acceleration alpha equals 1 RAD S minus 2. 1 revolution per seconds square seconds, right? In brackets, I cylinder equals mr square over 2. mr square over 2. Okay, find out find out the answer. Find out the answer.
Sir,
Yes. Angular acceleration 1 radius minus 2 radius minus 2 radius minus 2. Find out the tension must be applied to rotate the cylinder with an angular acceleration 1 radius minus 2. Brackets I equals mr square over 2. I equals mr square over 2. Okay, find out. First of all, we have to find out the I value. What is the I value? I equals mr square. M mean 50, r square mean 1 square over 2, 25 kg m square. It's your I value. Okay. Then find the tau equals I alpha. Tau equals I alpha. Tau mean into 1. T into 1. I mean 25 into 1 or 2 equals 25 Newton. Okay. Right. Okay.